All right, the last method for solving systems of equations this week that we're going to take a look at is solving by graphing. When we graph these ordered pairs, remember we want them in slope-intercept form so that we can easily put them on a graph. We can also use our calculator to help us with this when we use our calculators in class tomorrow. Solving systems of equations by graphing works best when the equations are in slope-intercept form. If you are given two equations in slope-intercept form, it's very simple just to type them in your calculator into y equals and find where they intersect. The solution to a system of equations is where they meet at an intersection point. So looking at our first example, we have 2x minus y equals 4, and we have y equals 1/3 x plus 1. You'll notice the second equation is in slope-intercept form, that's y equals mx plus b, but the first one has not been solved for the y value yet. So we're going to solve this for the y value before we begin graphing. To solve for the y value, we're going to split our equation down the equals. We're going to subtract 2x from both sides. When we subtract 2x from both sides, we get a negative y equals negative 2x plus 4. Remember that we cannot combine the x and the 4 because they're not like terms. We have a negative 1 in front of y. We need to get the y by itself by dividing each side by negative 1. And that's going to give us y equals positive 2x minus 4. Now that both of these equations are in slope-intercept form, we can graph them on our graph. I'm going to graph the first one using my red pen. So we have y equals 2x minus 4. That means our y-intercept, our beginning, is at negative 4, and our slope is 2 over 1. Remember, slope is rise over run. So we're going to begin at negative 4. Our rise is 2, our run is 1, and we can continue that on your graph, so you're doing this on your paper as well. And remember that the opposite of rising 2 and running 1 is to go down 2 into the left 1, and we make our line through all of these points. You'll want to remember to continue it off the graph and to put your arrows on either end because this line does continue. Now, the next equation we had was y equals 1/3 x plus 1. So we're going to graph this. It's already in slope-intercept form. We're starting at positive 1 on the y-axis. Our slope is 1/3. That means we rise 1 and run 1. Rise 1 and run 3. Rise 1 and run 3. And we graph our slope with each point. We can go down 1 and left 3 as well. I'm doing this in the blue. So now we're going to draw our line through each point. We're going to put the arrows on the end. Now, our solution, the solution to a system of equations, is an ordered pair that would work in both equations. So in this problem, our ordered pair that is on both lines, that works in both equations, is right here in the where they intersect. So their point of intersection is the solution. This point, this ordered pair, is 3, 2. So our solution to this system of equations is the ordered pair 3, 2. Now, to check your solution for a system of equations using a graph, it's very easy to pull up the table menu when you're using your calculator. Our equation, our second equation, we transformed and we got y equals 2x minus 4. So I'm going to use that for y1, and then we're going to use y equals 1/3 x plus 1 for y2. Now, when the value of x in my table is negative 1, if I had 2 times negative 1 minus 4, my equation would be at negative 6, and we saw that on our graph. When we're at negative 1 on the x-axis, we were at negative 6 on the y value for the first line that was red. If we plug in 0, our y-intercept for our line was negative 4. If we plug in 1, well, 2 times 1 minus 4, our next point on our graph, was at negative 2. If we plug in 2, 2 times 2 is 4, minus 4 is 0. It crossed the x value, or the x-axis, at 0. And then if we plugged in 3, 2 times 3 minus 4 gave us a value of 2. Looking at our next equation, when we plugged in when we looked at the graph, if we had an x value of negative 1, well, 1/3 times negative 1 is negative 1/3. And negative 1/3 plus 1 is 2/3. So that ordered pair would be at negative 1 2/3. If we plug in 0, this crosses the y-axis at a positive 1. We're looking at our second equation, y equals 1/3 x plus 1. If we plug in a positive 1, 1/3 x plus 1 is 1 1/3. If we plug in 2 for x, 1/3 times 2 is 2/3 plus 1 is 1 2/3. And then if we plug in 3, well, 1/3 times 3 is 1. 1 plus 1 is 2. Now, when we look at your table, you want to find where your y values are the same. And if we look at this table, in the very last column, the y values match. They're both 2, so that means the ordered pair 3, 2 is a solution for both of these. It's an ordered pair on both lines. Hey, taking a look at example 2, we have y equals negative 2/3 x plus 1. That is already in slope-intercept form. Our second equation we have is 2x plus 3y equals 9. We're going to solve this for y. We subtract 2x from both sides. Our job is to find the y by itself. We get 3y equals negative 2x plus 9. We cannot combine those. They're not like terms. And then we divide everything by 3. So we get y equals, well, negative 2x divided by 3 is negative 2/3 x, and 9 divided by 3 is 3. So our two equations are y equals negative 2/3 x plus 1. That's our first equation. Our second equation is y equals negative 2/3 x plus 3. So starting with our first equation, I'm going to graph this using red. We have negative 2/3 for our slope and 1 for our y-intercept. We're going to start at 1 on the y-axis. A slope of negative 2/3 tells us to go down 2 and right 3. Down 2 and right 3. Remember, if we have a negative slope, our line decreases from left to right. We could also go up 2 and left 3. Up 2 and left 3. And then we're going to draw a line through all of the points that we just graphed. When we draw the next line, we have y equals negative 2/3 x plus 3, so we're going to start at a positive 3 on the x-axis. If our slope is negative 2/3, we're going to go down 2 and right 3, down 2 and right 3, down 2 and right 3, or we can go up 2 and left 3. You'll notice that these two lines have the exact same slope, and we know that when we have two lines that have the same slope, these lines are parallel. If we have lines with the same slope, that means they are parallel lines. If they have different y-intercepts, they're going to cross the y-axis at different points. We're looking for where these two lines intersect, and we notice that when we look at these two lines, they will never intersect. Parallel lines do not intersect. So we would say that there is no solution. A solution is an ordered pair where they cross or where they intersect that works for both equations. So taking a look at these two, we had y equals negative 2/3 x plus 1 and y equals negative 2/3 x plus 3. And we're going to look at a table of values that would match these two equations. Our first equation is going to be y1. Our second equation will be y2. If we plug in negative 1 for the x value, well, negative 2/3 times negative 1 in our first equation is positive 2/3. And we would get positive 2/3 plus 1 is 1 2/3. If we plug in 0, this crossed at 1 on the y-axis. If we plug in a positive 1, negative 2/3 times 1 is negative 2/3, and negative 2/3 plus 1 is 1/3. If we look at 2, negative 2/3 x times 2 is negative 4/3 plus 1. Negative 4/3 plus 1 is negative 1/3. And then if we plug in a positive 3, negative 2/3 x, and 3 is x, so negative 2/3 times 3 would be negative 2, and negative 2 plus 1 is a negative 1. So there are the values that would be ordered pairs on our first line. On our second line, if we plug in negative 2/3 times negative 1 for x, starting at the top of the table, negative 2/3 times negative 1 is positive 2/3, and positive 2/3 plus 3 is 3 2/3. If we plug in 0, negative 2/3 times 0 plus 3 is 3. That's where it crosses the y-axis. When we plug in 1, negative 2/3 x plus 3, and negative 2/3 times 1 is negative 2/3 plus 3 would be 2 1/3. And then negative 2/3 times 2 is negative 4/3 plus 3 would give us a value of 1 2/3. And then when we plug in 3, negative 2/3 times 3 is negative 2, and negative 2 plus 3 is positive 1. So you'll notice in the table that we have that each of these, this is going down by 2/3 each time. And this is also going down by 2/3 each time. That means these two lines are never going to cross because their slopes are the same. There is no solution. There will not be an ordered pair that matches for both. Alright, for our last example, we have y equals negative 2x plus 3 and 4x plus 2y equals 6. Our first equation has been solved for y. It says y equals negative 2x plus 3. That will be easy for us to graph in just a minute. The second equation, we're going to solve for y, same steps as before. We subtract 4x from both sides. We get 2y equals negative 4x plus 6. And then we divide everything by 2. So we have y equals negative 2x plus 3. So here's our first equation. And here's our second equation. We're going to graph both of those. Starting with y equals negative 2x plus 3, we're going to have our rise over run. We're starting at positive 3 on the y-axis. We go down 2 and right 1. That's the slope of negative 2. Down 2 and right 1. Down 2 and right 1. We continue this, or we could go up 2 and left 1. Remember, that's the same thing. And we draw our line through all of these points. After we've drawn our line through these points, we're going to take a look at the next equation. Our second equation is y equals negative 2x plus 3. We're going to make that a slope of negative 2 over 1. That's our rise and our run. We're going to start at positive 3. We're going to go down 2 and right 1, down 2 and right 1, down 2 and right 1, or we can go up 2 and left 1, up 2 and left 1, and we're going to draw a line through these points. You'll notice that on your graph, these points are the exact same line. These two lines had the same equation, and now they have the same line. So if they have the same line, the points where they intersect are everywhere on this line. That means there are infinite solutions. Any point that matches both of them is a solution. So this one has a solution at every single point on the graph. When you check this in a table, our two equations were both y equals negative 2x plus 3. We'll use the first one for y1 and the second one for y2. If we plug in a positive or negative 1, negative 2x times negative 1 is positive 2, and 2 plus 3 is 5, so our first value for y is 5. When we plug in 0, our y-intercept was 3. If we plug in 1, negative 2 times 1 plus 3 is a positive 1. Plugging in 2 would give us negative 4 plus 3. That's a negative 1. And plugging in 3, negative 2 times 3 is negative 6. And negative 6 plus 3 is negative 3. When we look at y2, our second equation, if we plug in negative 1, well, negative 2 times negative 1 is positive 2, and 2 plus 3 is 5. Then we plug in 0. Negative 2 times 0 plus 3 is 3. That was the y-intercept. If we plug in 1, we would get out a positive 1. If we plug in 2, we get out a negative 2 for the y value. If we plug in 3 for x, we get out a negative, this one should be a negative 1, I apologize. So if we plugged in 2, negative 2 times 2 is 4, 4 plus 3 is negative 1, and the very last one, when we plug in 3, negative 2 times 3 is 6, and 6 plus 3 is, negative 6 plus 3 is negative 3. You'll notice that on this table, the y values match. That shows us that every single point that is on the first line is also a point on the second line, and that tells us that there are infinite solutions.